In Chapter 2, Part 2, we're going to continue looking at the chemistry content by discussing elements and atoms. We're also going to describe subatomic particles and their charge, defining atomic number, ions, molecules, hydrogen bonds, and then lastly in this section explaining the properties of water. So to begin with, we know that elements by definition are the fundamental forms of matter, and then we know that matter has its smallest units, which is what we would call an atom. And so some brief examples of atoms that you see on the screen, like an oxygen atom, carbon atom, hydrogen atom. Now, as far as atoms are concerned, we've always been told that atoms consist of three subatomic particles: protons, neutrons, and electrons. Now, these three particles differ in their charge. They also differ in location. So for protons and neutrons, we know that protons have a positive charge, neutrons have no charge or are neutral, and they're both found in the nucleus of the atom. So if you look over to the image on the right, if this was a carbon atom, you would notice that protons and neutrons are found in the center or the nucleus. The electrons, the third particle, they have a negative charge. They're found in what we call electron clouds. So they're found in these outer regions, and so the E with the negative sign stands for the electrons. So again, protons and neutrons on the inside of the atom, and then electrons circling in the clouds. Now, as far as the atomic number is concerned, I'm sure at some point you've had to learn the periodic table, learned some of the elements on the periodic table, and so you know that every atom has an atomic number. And the atomic number is the number of protons that are found in the nucleus. And so again, protons have a positive charge, so the atomic number describing the number of positively charged particles that an atom has. Now, one of the things that we wanted to address is the topic called an ion, because the rest of the semester we're going to be dealing with ions. If you take anatomy in the future, you're going to hear a lot about ions. So before we establish what an ion is, we need to establish what a neutral atom is. See, for all of the atoms that we deal with in life sciences, most of them are going to be considered neutral. Now, if something is neutral, that means it has no charge. So for an atom to be neutral, in order to get no charge for the overall atom, you would have to have an equal number of protons and electrons. Because remember, protons have the positive charge, electrons have the negative charge. So if the positives and negatives are equal, then it causes the atom to be neutral. So what an ion is it's an atom that has gained an electrical charge. And the way that it has gained an electrical charge is it either lost a proton or gained a proton. It either lost an electron or gained an electron. So for example, I'll just put some numbers to it. Let's say that a certain atom had 6 protons and 6 electrons. So because it has the same number of protons and electrons, we would consider it to be neutral. But let's say that that atom that had 6 protons and 6 electrons all of a sudden loses an electron. So now the protons and electron number is not equivalent. So it has 6 protons, only 5 electrons, which means it's no longer neutral. It has one more positive than negative, so it has gained that positive charge. So an ion, again, is going to be an atom that has gained an electrical charge, either by losing or gaining electrons. Some ions that you may have heard of before, like in the human body, we think of things like sodium, potassium, chloride, all of which have gained an electrical charge. Now, why in the world does this matter? Well, one of the big things that we're going to look at in this section is a molecule. Molecules are 2 or more atoms held together by chemical bonds. And we're going to learn a little bit later on what actually allows certain atoms to bind together actually all deals with the number of electrons that they have. Again, we'll deal more with this in the next section. But a molecule, 2 or more atoms are held together by chemical bonds. They can be composed of the same type of atom, so multiple oxygens held together, or it can be composed of different atoms, like 2 hydrogens and an oxygen that make water. Forming these bonds together actually helps to make the atoms stable. So water being a very important molecule that we deal with in living things. Another thing that we want to look at before we look at the properties of water is we want to look at something called hydrogen bonding. Now, definition of hydrogen bonding is it's a weak chemical bond. Keeping in mind it's weak, you're going to want to remember that later on. It forms when partially positive hydrogen is attracted to partially negative a partially negative atom. So if you look at the example below, Water is a great example of hydrogen bonds because you have the hydrogens that have a positive charge. They're going to be attracted to the negative oxygens, and so by doing that it holds these molecules, it holds these atoms together to form water molecules. Now if we look at some of the basic properties of water, there are really just 4 basic properties, and these 4 basic properties actually establish some special functions of water. So first off, we know that water is a good solvent. Second, we know that it facilitates chemical reactions, it is cohesive, and it moderates temperature. So let's look at these 4 in a little more detail. So first off, we said that water is a good solvent. In order to understand that, we have to define a solution. So a solution by definition is a chemical mixture, and any mixture is going to be composed of solutes and a solvent. So the solute is the substance that dissolves in the solvent. An easy way to remember it is the solute is what is being dissolved. The solvent, on the other hand, is the substance that dissolves the solute, or again, an easier way to remember it, the solvent is what is doing the dissolving. So because of its polarity, water can dissolve most solutes, which typically is why it's called the universal solvent. So you think about coffee. You know, for a lot of us, when we go to drink our cup of coffee, a lot of people don't like it black. A lot of people like to add sugar to their coffee or some type of sweetener. So when you put that sweetener into your coffee, as you stir, the sweetener dissolves. So the sweetener would be the solute. The water that makes up the coffee, well, that would be the solvent. You also see the same thing, when you put salt in water and it dissolves. The salt being the solute, the water being the solvent. So first property is that we know that water is a good solvent. Now, a couple of terms that we always associate with solutions, and it has to do with how they respond to water. So the terms are hydrophilic and hydrophobic. So if a substance dissolves in other polar molecules, like in other words, if it dissolves in water, we consider it to be hydrophilic, because the term hydrophilic, hydro meaning water, philic coming from the Greek word philios, which means love. So if a substance is considered to be hydrophilic, it loves water, it will dissolve in water. So we think of things like sugars and salts. However, on the other hand, if a substance will not dissolve in water, we consider it to be hydrophobic. Phobic coming from the word phobia, which means to fear. So you think of things like oil that would never actually dissolve in water. A second property of water is that water typically facilitates chemical reactions. In other words, water allows contact between solutes in a chemical reaction. Now, we know chemical reactions, you typically have changes in the chemical composition of a substance, and in any chemical reaction, you're going to have both reactants and products. Reactants are what participate in the reaction. They're solutes that are going to be changed, and the product is the result. An example, A plus X yields or equals C plus Q plus R. So A plus X would be your reactants, C plus Q plus R would be your products. And water typically is what allows these reactants to produce the product. Third property of water is cohesion. Cohesion by definition is just the tendency of like molecules to stick together. So if we say that water is cohesive, we're saying that typically water sticks to water. The main reason is because of the hydrogen bonds that form in water that hold all these molecules together. A benefit of water being cohesive is you think about like plants. It allows plants to transport water from their roots up to their leaves, up to the top of the plant because the water molecules stick together. You've also probably noticed if you take a glass of water and you pour it out, even once the large majority of the water has been dumped out, there'll still be some water left inside of the glass because that water molecule is sticking to the water. It also, we use the term adhesive, it's also sticking to the glass itself. But water has that tendency to stick together. Maybe you've noticed, like in mud puddles in your yard, that sometimes small bugs can run across them. Because the water molecules are holding so tightly onto each other, it forms basically a film on top, and so those small bugs are able to run across it. So cohesion says that water basically is attracted to water. And then finally we know that water moderates temperature. Water absorbs heat energy. And so what happens is, as the sun hits the water, or heat hits the water, to begin with, the water absorbs that heat, and so you don't see an initial change. But what eventually happens is the hydrogen bonds get disrupted, they eventually break apart or start to kind of break apart, and when that happens, it causes the additional heat to raise the temperature of the water. So a benefit here is that, yes, we know that the temperature of water can be increased, but we know that it's going to be something that happens slowly. So you think about living things who are predominantly made of water, because temperature does not change, or because water does not change temperature quickly, neither will we.